What's up, everybody? The infamous Joe G here. And in this video, I want to show everyone how you can utilize dynamic secrets in Ansible Automation Platform with CyberArk's Central Credential Provider. If you own CyberArk today, then you probably already know how easy and secure it is to set up unique SSH private keys for each individual host that you have in your environment. Now, this is because CyberArk's identity security platform can automatically manage those SSH private keys by automatically rotating them to keep it within your organization's compliance policy. But what happens when you want to use an automation platform like Ansible Automation Platform to execute operations on a group of those hosts, maybe tens, hundreds, or even thousands of them, each one having its own unique SSH private key? This would end up creating a single job template for each host that needed to utilize a unique private key, because unfortunately, we can only assign a single machine credential to a job template in Ansible Automation Platform. But fortunately for you, after you finish this video, you'll understand how you can utilize a single playbook to accomplish your goal of retrieving unique SSH private keys just in time for each host that will be connected to. So, without further ado, let's get started. First, we're going to start off on GitHub, and I'm going to show you how we have dynamic secrets set up for both the Central Credential Provider as well as for Conjur Secrets Manager, whether it's self-hosted or Conjur Cloud, our SaaS-based version. First, let's target the Central Credential Provider method of doing this, and then we'll take a look at how it's configured in Privilege Cloud, and then we'll take a look at how it works in Ansible Automation Platform, and we'll come back here, take a look at the Conjur side of things, and then do the same thing. So to start off with, I do have a playbook here for dynamic secrets for CCP that will be triggering in a job template in Ansible Automation Platform. If we take a look at what is contained within this playbook, I'm targeting all hosts, but I don't want to gather any facts from those hosts, because the idea is that we don't have the private key needed in order to authenticate via SSH to the remote node. And because of that, we can't connect and gather facts before any of the different roles or tasks down below execute. So we'll say gather facts to no, and that'll prevent the error from occurring that will stop us from being able to make it to this role where we're going to actually be fetching the unique private key. We're going to be using the CyberArk.paz collection for this. You can find details on it out on Ansible Galaxy or in Red Hat's Automation Hub. This is where the role definition lives that we're going to be triggering, and that is the playbook. So most of the tasks and everything that's going to be executing is actually found in this directory here. So we'll go back a level and we'll come into roles, CCP dynamic secrets, and we'll take a look at our tasks. And in here we have a main.yaml file that defines all of the tasks that will run when this playbook is executed. And so the first thing I'm doing is defining a block. And this block is going to allow me to set certain parameters to all of the different tasks that take place in that block, rather than needing to set it individually for each particular task that takes place. But to take a look at this block statement here, first we're going to be retrieving the SSH private key from CyberArk. And this is really where the magic happens. We're going to be logging in to the Central Credential Provider using the CyberArk_credential module that is a part of the CyberArk.paz collection. And we're going to be referencing an application ID and then providing a query to the Central Credential Provider that will then hopefully return our private key contents that we can then handle from there. So we have our safe and our object keys in this particular query statement. And the way that the object is configured is really the trick here, right? So we know that there is a naming convention when you onboard accounts into Privilege Cloud or PAM for CyberArk. And that naming convention goes something like this. First, it's the device type of the particular account or credential. And then it is the name of the platform that is managing that particular account or credential. And then you have the address of where that particular credential or account lives, and then the username that is associated with it. And so you could probably already tell, since I highlighted it, what we're doing here is instead of setting a static address, we're providing the inventory host name instead, which will be the address of the remote node we are connecting to. So if all goes as planned, that means that for every SSH connection attempt that's made against a remote node by Ansible, it's going to be plopping in the address it's connecting to here, and we should get back that unique SSH private key that we need for that particular address from CyberArk PAM or Privilege Cloud, and then we can utilize it later to make the connection. But first, we need to do a little bit of handling of the contents that are returned through this, because right now we're registering it into a variable, but it's a JSON response that's returned from the central credential provider because we're hitting a REST API endpoint. And so we need to work with that particular JSON response. Now, I've got a couple debug tasks here. This is not something I would recommend for production, but for me to get an idea of whether I'm getting the right content back or not, it's good to do. But at the end of the block statement, some of the parameters that are applied will prevent this information from being presented in the logs. And we'll take a look at that here in a few. The next task that we handle is creating what's called a temp file in Ansible. And this temp file exists only for the execution of this playbook. So it's a part of the execution environment that this entire playbook is going to be run within an Ansible Automation Platform. And so what we're doing here is we're creating a file, we're giving it the suffix of key, and then we're registering that file information, the metadata of that file, to the variable temp key. And then we're going to set 0600 on the SSH private key so that it is secured with the proper file permissions for use. And we're going to target that temp key variable but specifically the path, right? So we're going to say .path so that we're referencing the path and not the actual contents of the file or anything like that. And then our mode is going to be 0600. So in this next task, we're going to write the SSH key to a temp file now that we just got done messing with and creating the path for, the proper file permissions for. And we're going to use Ansible's built-in copy module in order to do this. And it's going to copy the content from the central credential provider's response, and it's going to put that content in the destination that is our temporary key's path. So we're giving it the path to where the temporary key lives with the proper file permissions. And we're saying, hey, take the content, which equates to the password or the key in the central credential provider's JSON response that was returned. And we're adding that content and basically creating the private key file ourselves as a temp file that will be destroyed at the end of this run. And then finally, we're going to set that fact as Ansible SSH private key file, which is a fact that Ansible knows to utilize in order to authenticate SSH connections, and we're going to give it the path to the temporary key. Now, if we were to use usernames and passwords, we wouldn't need to do any of these steps here for the temp key. We wouldn't need any of that. We'd be dealing with the username and password, and so we could go immediately to setting the fact and setting the Ansible SSH password variable instead to the content, which would contain the password at this point and not the key. But we're using an SSH private key today, and so we need to go through these methods. And then finally, we get the 2 parameters here that encapsulate the entire block statement of tasks we just ran through, where we're delegating this to the local host. We're not trying to connect to anything because we don't have anything to connect with yet. So we're delegating this to the local host, and then we're saying no log yes. And that's going to prevent any information from being output to the logs, especially our debug statements here, right? So if I'm debugging this, I can switch no log to no, and then I'll start to be able to see all of that information. Or, I can just keep this yes and mask everything, or just remove these as well. But I like to keep them there rather than needing to constantly commit to Git all of these changes. It's easier just to change a word than to change all of that code up there with the debug messages. But once that block runs and we get the SSH private key, it's set to the fact, then we can immediately do our task that connects to that remote host. And in this case, we're running a shell command, hostname. And so it should just return the hostname, right? That's the same as just typing hostname in our terminal, hitting enter, and getting back the hostname. So that's what's going to occur here. But obviously, in order to get back the right hostname, it needs to successfully authenticate via SSH with the unique private key. That's the key here, right? No pun intended. So that's the setup. That's what it looks like from GitHub. This is the playbook, or the role we're going to be executing from the playbook that's at the root directory here. All right, let's go ahead and log into my tenant now and take a look at what I've got going on. Go ahead and authenticate. I'll use my passkey, and I'm in. So it's going to take me to the service that I was last viewing before I logged out, which was Privilege Cloud. And that's perfect because that's exactly where we need to go. So the Central Credential Provider is going to be utilizing and retrieving credentials from within Privilege Cloud in my case. And so I've created a safe. And in that safe, I have 2 different accounts. The safe we're going to be targeting for this is my pin inf lin sudoers safe. And so this is all of the sudoers associated with Linux EC2 instances in my environment. Actually, before I go to accounts, let's pop back into that safe and take a look at the members. I can kind of talk to you guys about the members a bit because I've got quite a few on it. And so taking a look at the safe members, you'll notice that I have my prov underscore username, which is required for the app provider user of the Central Credential Provider to be able to access this safe. And then I'm going to be using this application ID here, Ansible Playbook. So it also needs access to this safe. Now, if you're familiar with my how to install, configure, and test Central Credential Provider video, that's also on YouTube here, linked in the description, you'll recognize that there is a safe member missing here. And that safe member contained 0 permissions, but in that particular video, it was required to be a safe member. It was called AIM Web Service. In newer versions of PAM and Privilege Cloud in the Central Credential Provider, that's no longer necessary. The AIM Web Service is still an application ID in our application section, but it no longer needs to be applied to every safe that's going to be working with the Central Credential Provider. Just by it being present in the application section is all that's really necessary nowadays. So as long as you have that AIM Web Service listed here, then you're good to go. And again, we'll be using the Ansible Playbook app ID that's here, and it's set up for the DNS and the IP address of my Ansible Automation Platform's controller. So that's going to be the quote-unquote local host that we're delegating the playbook to. Now, as far as accounts are concerned, I did deploy 2 EC2 instances with 2 different SSH key pairs to kind of showcase, this demonstration. And so they're newly added. I can filter on that. And then we've got our 2 EC2 users here. So I've got This particular account, that if we take a look at the details, it's aligned with my Ansible client 1. And so this is an SSH key that's been uploaded. So everything will reflect SSH keys, not passwords or anything like that. Okay. Retrieving the key, retrieving the password, whatever, same idea. Okay. But I've got two of those, two unique ones, one for this EC2 instance and then one for this one as well. So those are both onboarded. The safe has the proper permissions, and therefore the CCP should be able to retrieve it as long as it comes from the proper request store and matches all of the different authentication methods that I have applied to the application ID here in Privilege Cloud. Now, as far as Privilege Cloud is concerned, that's done. Central Credential Provider, that's done. Let's bounce into Ansible Automation Platform now and take a look at that. We'll give it a second to connect and start up the step recording, and then it should land us on our Ansible Automation Platform dashboard. Here we go. So I've got some other things going on here, but I'll kind of point out what we're going to be working with today and kind of explain things. First and foremost, for us to be able to communicate to the Central Credential Provider, we're going to need to set up what's called a secret lookup for the Central Credential Provider. And the one that we're going to be using for today's purposes is this infamous DevOps CCP that I have scoped to the controller. You'll notice I have some teams in here, Ops Team 1, Ops Team 2. They have their own application IDs that they can utilize for their own teams to get access to their own secrets. They cannot see this one. I'm logged in as an administrator right now, but if I was a member of Ops Team 1, I would only see everything labeled Ops Team 1. So a pretty cool way that you can utilize the RBAC in Ansible's automation platform to further segregate what teams can do within there and what they can access from a credentials perspective. But for today, we're going to be focusing on this one. And if we take a look, I'm targeting my CCP. My application ID has been set up, and I believe that's about it. So the app ID is set here. Where the CCP is what we're doing. And so what this basically equates to is somewhat of a connection broker. So we're kind of configuring the connection details here, and then we're going to reference this as our lookup in actual credential types. There's more information on this on YouTube. The video linked down in the description will walk you through how to set this up, not only for the Central Credential Provider, but also for Conjure as well in that video. Let's go back to credentials for a second, though, because we're going to be using a couple different ones here. We're going to be using this placeholder. So this placeholder I created in order to be able to add my one machine credential to the job template that Ansible allows. And both of the EC2 instances that I'm going to be connecting to use the username EC2-user. So to simplify things, I went ahead and set this dummy credential username to EC2-user. So what this is going to do is when the job template runs, it's going to get the Ansible SSH username from this value and utilize that. If this was any other value, or maybe we're connecting to Ubuntu EC2s and the username is Ubuntu instead, we would need to set an additional fact in the playbook to set Ansible _SSH_user to the proper username that we need to reference as part of the SSH connection. But since things are pretty simple in my environment, I can get away with it this way. You can use this method for each individual username that you might be using. If you're on AWS, you could have one for EC2 user, one for Ubuntu, one for whatever, and then just have 3 job templates based on the username for your unique dynamic secrets retrieval. Or you can work it out in the playbook and set the fact ad hoc, right, on demand. Some other credentials that we're going to be using are not in here, right? So we're going to be pulling from straight through the playbook. So we really just need the dummy credential on there so that the playbook will run properly. Without the machine credential, it doesn't really know that there's any user needed for the SSH connection. So we're going to apply at least that. And so that's all here in the template section. These templates, you point to a playbook that you want to run, and then you can define the environment around the playbook's execution. So for CCP dynamic secrets, I have this job template here. And so this is set up to run. It's running against my AWS inventory. So this is based off of a tag of my EC2 instances. I can pull in the ones that are meant specifically for this particular demonstration. All right, I'm pulling in my project from GitHub, the GitHub repository that I showed you at the beginning of this video. I'm using a CyberArk execution environment. This is a custom execution environment built off of the default one that adds on top the CyberArk.paz and CyberArk.conjure collections for access within the execution environment. And then I'm targeting that YAML CCP dynamic secrets playbook that we were looking at earlier in GitHub. Now, that playbook does have a couple variables here that I need to define, or I can accept the defaults that are provided here. And so I've got a couple example values here. I'm going to need to change these. And in order to change these, there's two ways I can handle this in Ansible's automation platform. If they're static and I don't need to worry about people defining them, I can define them in this variables section here, either YAML or JSON, and it's just basically listing them out like this. So this is how we're going to be doing it today. Another way of doing this is if you want the user who is triggering and launching the job to be able to provide the information before the execution. And to do that, you would create what's called a survey. And so when you create a survey, you can add questions and different answer types and things like that. So you can create a text area. You can create multiple choice, right? You can do multiple select. There's all sorts of different options here for you to build out a form that needs to be answered with, potentially default choices. Like if we were to go to, text or something, you can create a default answer similar to that vars file that you saw. But this is like human attended, right? Launching, the human can put in their information and things like that, and then go ahead and launch this off. But for this particular case, I'm going to keep everything static. This will never need to change. And so when we launch this, it will launch. And the first thing it's going to do is connect out to GitHub and make sure that it has the latest version of the playbook that it's running. And once it does that, it's going to then look at the secrets that are applied to the playbook and try to retrieve them from the credentials section. The only secret that's applied is the dummy secret, that one where it's just called placeholder. And so it's just going to be providing the EC2-user username. Everything else is going to be fetched from the Central Credential Provider just in time and provided back. And you can see where this is happening. We're able to retrieve both SSH private keys here, create the temp file, right? Set the fact. And then down here, let me reload this output because it kind of paused on me. You can see we've got two changes occurring here. And if we select this change, choose JSON, we can see the command that was run is hostname, and the standard out is the host name, right? The IP address.joegarcia.dev. That is the host name of the EC2 instance that we connected to. If we were to look at the second one, it would be different because it was pulled from a different SSH private key to connect here to a different endpoint. And so right there, we've retrieved two different SSH keys and authenticated to two different remote targets dynamically fetching as needed based on the inventory host name, the SSH private key that's unique to each of these situations, and then we're properly using them. So here you could start to scale this out to tens, hundreds, potentially thousands, right? And you can start chugging through your OS patching and making the connections and fetching those secrets that you need. So hopefully you understand now how you can utilize CyberArk's Central Credential Provider to be able to retrieve just-in-time secrets that are needed by Ansible Automation Platform to connect utilizing a unique SSH private key to remote hosts it needs to perform actions on. In the next video, we'll take a look at what it takes to set up this entire scenario for Conjur Enterprise and Conjur Cloud. And until then, stay secure.